Okay, so here's a look at a sample distillation setup. In our organic chapter, we learned how alcohols can be oxidized using various oxidizing agents like potassium permanganate. The one we typically use is acidified dichromate. Depending on the alcohol, whether it's a primary alcohol or secondary alcohol, we can actually oxidize that OH hydroxyl group into other functionalities. Let's imagine here, right now I just have boiling water assimilating my alcohol. Let's imagine that I have a primary alcohol in here, which would be a alkane having that OH functionality. The carbon here would be terminal, so it's only holding maybe 0 carbons, but at maximum 1 carbon. Because it is a primary alcohol here, you would throw an oxidizing agent inside, so add in some acidified dichromate here. The heat comes from this hot plate here. As that sort of starts boiling and starts oxidizing here, the primary alcohol is going to oxidize first into a aldehyde. And then if we just sort of left it for longer in more of a reflux setup here, it can actually further oxidize to become a carboxylic acid. Because our aldehyde sort of intermediate, it's only has dipole-dipole intermolecular forces. It doesn't have access to the hydrogen bonding that the alcohols or the carboxylic acid has. It's going to be the first chemical that boils off. So imagine I have a primary alcohol in there, I have the acidified dichromate here oxidizing here. As I create the aldehyde is going to be the first thing that actually boils off, separating from our starting primary alcohol, as well as perhaps some carboxylic acid that eventually gets formed. That aldehyde is going to travel up this rubber hose here. Again, it's going to encounter this really cold environment of the water condenser here. The central chamber here is like a tunnel. That part there is unconnected to this outer condenser wall here. The condenser we just fill in with cold water just to provide a cold environment, so that as the aldehyde vapor makes its way to the top here, it recondenses into a liquid. We give this condenser a little bit of a slant here and there. I can just collect just the aldehyde, and I would have separated it from the primary alcohol and the carboxylic acid. If we were just interested in the carboxylic acid product, instead of doing a distillation and trying to collect that aldehyde sort of precursor, I would just do more of a reflux setup. I'll do another tutorial on that one there. And that one basically just allows this boiling to continue over and over again, and we basically fully oxidize it to carboxylic acid. If this alcohol here assimilated, if this were a secondary alcohol, we can get it oxidized to a ketone functionality. But due to no further sort of oxidation and breaking of the carbon skeleton here, that's the extent of that. And remember, for a tertiary alcohol, because the carbon skeleton is fairly rigid here, whether you do an oxidizing agent, it won't actually perform any oxidation reaction. So this is typically the setup we use for separating things based on different boiling point. In this chapter, we're looking at separating aldehydes from the starting primary alcohol before it further oxidizes to form carboxylic acid. Thanks, guys.